Okay, I think I'm gonna call this series part 2. So there's a theorem that says that if a series converges, so this means the series converges, then the sequence of that series goes to 0. And a corollary to this would be sort of like the contrapositive of this statement, and it's called the nth term test for divergence, which says that if an, the limit of an does not exist, or the limit as n approaches infinity of an is not equals to 0, then the series diverges. So I'm going to put diverges. This guy right here is called the nth term test for divergence. So a lot of series diverge in the following sense. This series, which is n squared, as n goes from 1 to infinity, diverges because the n squared goes to infinity, so the limit does not exist. This other series, we'll call it B, n divided by n plus 1, as n goes from 1 to infinity, diverges because the limit of n divided by n plus 1 is equals to 1, which is not 0. Another series that diverge is this series right here, that is sort of like minus 1 raised to the n plus 1. The series diverges because, so BC stands for because the limit as n goes from to infinity of minus 1 raised to the n plus 1 does not exist. So D and E, I write D and E for doesn't exist because the limit is either 1 or minus 1, so it's not a unique number. Okay, so this is called the nth term test for divergence. When a series, let's say you wanted to see whether this series converges or not. So you have this series, that is a series that goes from 1 to infinity of 3 to the n minus 1, like this, divided by 6 to the n minus 1. You can write this as follows. This is the series as n goes from 1 to infinity of 3 to the n minus 1 divided by 6 to the n minus 1 minus the series as n goes from 1 to infinity of 1 over 6 to the n minus 1. And if this series converges and this series converges, then the original series converges. So let's see if these two series, if at least one of them diverges, then the whole series diverges. The first series right here, it's the series that goes 1/2 raised to the n minus 1 minus the other series is n equals 1 to infinity of 1 over 6 raised to the n minus 1. So for the first series, it's a geometric series. The first term is 1 and the ratio is 1/2, so this is 1 divided by 1 minus 1/2. And the second series, it's the first term is 1 and the ratio is 1/6, so 1 minus 1/6, like this. You get 2 here, you get 6 over 5 here, so therefore altogether you get 4 over 5. So that's what the value of the original series is. All right, what else? Let's see. Oh yeah, sometimes people use geometric series to express a rational number into a ratio of two integers. So, like for example, 5.23, blah blah blah, can be expressed as follows. This is equals to 5 plus 23 over 100 plus 23 over 100 squared plus blah blah blah. And you can take, this is 5, and then you can take 23, so let's do 23 over 100 cubed plus blah blah blah. You can take the 23 over 100 from that series, and then you get 1 plus 1 over 100 plus 1 over 100 squared plus blah blah blah. And what's inside the parentheses is a geometric series with first term equals to 1 and with ratio equals to 100. So this is just that 5, and then this is the 23 over 100, and then this is the geometric series, which is 1 divided by 1 minus 100, like that. And out of this, it will give you 5 plus 23 over 99. And then adding that 5 times plus 23 over 99, you get 518 divided by 99. And so we have expressed this number as a ratio of two integers. Okay, so let's see. I think I'm just gonna go ahead and do maybe a couple more examples. Okay, so where is it? I don't seem to find it, so I'm just gonna go ahead and stop right here. And so, okay, so we're gonna call this series part 2.